Hey friends, it's Frankie the Polymer Investigator. Welcome back. Today I want to discuss some key factors you need to consider when designing your plastic parts. In particular, today we're going to discuss a sewing machine bobbin case. So this kind of started back at the end of March when my roughly 50-year-old sewing machine finally died on me. It was one I had inherited from a great aunt about 8 years ago, and it was working fantastic. I noticed a couple of years ago that the tension control was starting to go. I took it to a sewing machine repair shop. They claimed to have fixed it. It worked for all of 10 minutes before it died again. So then I said, from now on, I'm just going to use the straight stitch. And that's all I really needed up until, well, actually, that's really all I needed. And then it finally gave out on me in March. Given the time of with everything going on right now, it was difficult to find a sewing machine online, and I couldn't exactly go in and buy one in the store because everybody was out. So I found what I thought was a really potentially great machine online, bought it. It took almost a month to show up, so it was about end of April that the new sewing machine finally showed up, and I was starting to experiment with it, and I noticed that this had a drop-in bobbin case instead of a front loading. So the front loading, the bobbin case looks something like this, where it's got, you put the metal bobbin in here, and then you use this lever to kind of hold everything together while you load it in. It's hard to tell, but pretty much you can see it's not focusing. Focus on it. But you can see that piece moving in and out, and that's what holds the bobbin in place while you are loading the sewing machine with it. And this other one, it has a top loading. So you can see that this is a plastic metal hybrid part. Pretty much the tension control is completely metal, but pretty much most of the rest of it is a cheap but still durable plastic. I'm going to guess it's ABS, but I don't know for sure. I'm not about to test it to find out. That's not what I'm going to be doing today. So I don't know if you can see, but there's a lot going on with this design. So when I started using the sewing machine, it worked fantastic. It worked great. Took me a little getting used to the fact that this one was a computerized versus a completely mechanical one that I was used to. And once I started to get a little braver and experiment, because it's got like 100 different presets for stitches, I found the lever, or the little sliding mechanism that controls the speed. So I got a little crazy in my experiments and I broke the sewing machine. So it took me a while to figure out what had happened. But in my taking the whole section apart and putting it back together multiple times, trying to figure out what was going wrong, I wound up destroying this case in the process. Let's see if I can demonstrate. You can see I don't know if you can see. It's not really focusing, but you can see it looks like somebody took a bite out of that leg. And then you can see there's I stabbed a hole in it. There's all sorts of other stuff kind of cut out over here. It's kind of gouges, scrapes of all sorts. Stabbed right through it here. I did all sorts of crazy things, and then there's the thread wrapped around and dug a really deep crevice in here. I tried fixing it at one point, and nothing I did would work. So what I eventually had to do was buy a new component, and those things are really hard to find on the internet. I suspect that there was a redesign involved, so when I was looking around online, I finally got what looked like the right thing, and turns out it's not. But it looks like this was like a previous design, and you can feel it is a very different, they feel very different in weight. This seemingly older design is much heavier, so it has a lot more plastic in it. And when I was measuring, the undercarriage is almost identical. So I don't know if we can show here, but you can see the design is nearly identical. I honestly can't tell the difference. So I started to measure up these fins. And on the supposed older design, they were more than twice as thick. So I was getting, you know, like 45 thousandths on this section that ended up failing on the other part. And on the part that failed, I got less than 20 thousandths thick, 20 thousandths of an inch. So it was obviously much weaker. And when you have thread wrapped around multiple times, just gripping tighter and tighter, of course it's gonna take a bite out of it. As you can see, that's what happened to my poor bobbin case. So a lot of things to consider when designing your plastic part is, one of the things that you're going to have to consider when designing plastic parts is, you know, how much plastic is it going to take to make this thing? How complex of a tool can you make? How complex of a tool is it worth it to make? For example, if you're going to be making, you know, hundreds of thousands of pieces, then it makes more sense to, you know, have a more intricate design as long as it prolongs the life of the piece or makes it, you know, better in some way. So I can see that they tried to do that between this old, you can see this older design was has a nice smooth beveled area, and obviously those fins on the bottom are thicker, and they're doing all sorts of, you know, the rest of the design is pretty much the same. Then when you look at the newer design, you can see that we still have this beveled edge for, you know, the thread to kind of ride up over it. You know, you have these ribs that are perpendicular to where the thread will go. And that's great. It takes out a lot of weight, but it does increase the complexity of your tool. So when you are designing stuff like that, you got to make sure that that's something that can be made. So that's when you're constantly, you know, in contact with the person who's going to be making the tool, or maybe not constantly in contact, but when you have something you think is ready, have them look at it and, you know, let them know for you if there's going to be any problems with them making it. Because if they're going to have a problem making it, then the price of your tool is going to go way up. The other aspect that they did was obviously they thinned out these fins. And this is something that I don't think they should have done, because it pretty much increased the ability for the part to fail. This is now a useless bobbin case. This is completely useless. It jams up my sewing machine every time. It actually will fatigue cycle my spring by moving it out of place. It will stretch it and pull it every which way, and it just kind of ruins my spring, which is, you know, the problem that I was having. So a lot of the things to consider is kind of, if you wanted to make something use less plastic or be a more efficient design, you need to make sure that whatever you do, it doesn't affect the amount of cycles that would cause the part to fail. So in this case, I love the fact that they took that smooth, heavy bevel and they just broke it up. It's awesome. There's a lot less plastic in there. It's great. It's a more expensive tool that way, but it's still awesome because you're removing material where it doesn't need to be. And that's all about, you know, redesigning your part and, you know, using the plastic in the right way so that it's where it needs to be. I would suggest in the future, and I imagine that this actually could be easily remedied with the tool that already exists, to make these fins a little thicker. Yes, you're gonna have to use a little bit more plastic in order to make this. I'm not sure why they chose that particular design element. There are other places that they could have saved material, in my opinion. If you look at this square hole, I think that square hole could have been quite a bit bigger. You could have saved a lot of material that way. I think this section here could have been opened up into a hollow potentially. Now I'm not sure how much that would complicate the tool design, but it's something that I would have considered. Just kind of removing some of the material from here as well. You got this spot here that's all free, so you might not have had to make it completely round. I don't even think you needed to make it completely round there. The thread does come up this way, so you could have easily just, you know, taken some material out of there. That's something else that I would have considered. Fortunately, after very much searching, the main reason that this one wouldn't work in my machine, I don't know if you can see, but there is a vertical tab here, and that was a hard stop on the machine when it would return. When the bobbin case would bounce around, that would actually stop it from going too far, and this design does not have it. Yeah, this little fin, no such fin over here. So unfortunately that didn't work, so I bought this thing for no reason. I was able to find this exact thing again, and now that I've fixed my spring issue, and now that I've completely lubricated the inside of the machine, I made everything nice and clean, it works great again, and I love the sewing machine. I would just suggest to people who are designing components like this to make sure that when you're taking material out, and that it's not going to affect the way that the part works. Now, if Singer was willing to make these a little bit more easily available, and then, you know, make these kind of almost a replaceable part, that wouldn't make me happy, because we're wasting plastic by making things that break easily, and wasting the plastic because it's just going to get thrown out. This is not going to end up being recycled because of the metal components and the fact that it doesn't even have a little recycling number on it, so you don't even know where to recycle it. So in my opinion, they shouldn't make these disposable. They shouldn't design these to be disposable. They should thicken up that section and make sure they don't break again. At least that's what I would do if I were Singer. A lot of their reputation was that these machines are tanks. You know, my grandfather was a tailor, and he swore by Singer sewing machines. He wouldn't use anything else. And that's kind of one thing that my dad had really taken away from knowing what my grandfather did for a living. At the same time, the Singer brand's reputation is based on how well the machines work and how long the machines last. So this is something that I would consider if I were Singer. Either fix it so that it's never an issue again, and then or if it's something that can't be fixed, which I find very difficult to believe, this should be very fixable. I would just thicken up those fins back up to the 45 thousandths that I'm getting out of this. I think that would make it a much more robust product. And I mean, you're already saving a lot of money based on saving the weight in here. And if it were to be redesigned again, I would take some more material out of this area. They did also, you know, take material out of that section too. I would make this square a little bigger. Just some things that would definitely, you know, that would reduce the weight, but not in a way that affects the way that affects the way the machine works. That's my 2 cents on designing parts to reduce weight. Just think about, you know, how the part is going to be used. Think about where everything is going to mate and function, what's going to rub against it, what could go wrong, what could potentially break this. And then if it's something that is breakable, you know, is it easily recycled? And if it's not, then maybe you should design it better. Think about, you know, what the part is going to be doing. Think about the ways that it could fail. Adjust your design to make sure that it either doesn't fail or is less likely to fail, or you design it to be recycled. And if you design it to be recycled, you need to think through the downstream of after it is, you know, after the person throws it out and how the recycling process works. Think about the tool. Think about what goes into making the tool. Think about what is physically doable when making the tool. Make sure it doesn't affect the way the part functions. If the sewing machine itself is going to break your component, then maybe you should design it to not be broken as much. Will normal use or even slight abuse break this component? And if it will break the component, can you design it in such a way that this would be avoidable? be creative within your constraints. The constraints actually are what cause you to come up with some pretty creative solutions. Hey friends, if you found this video useful, write yes in the comments below. I'll check through and make sure things made sense for you. If not, ask me a question and I'll do my best to explain it in the comments. And, you know, if you want to see more videos like this, give it a like, subscribe to the channel, and I'll see you in the next one. Bye.